Pluto is a faraway, elusive, and less conspicuous planet that was once considered a part of our solar system. However, recent groundbreaking statements from prominent astrophysicists like Neil deGrasse Tyson and Michio Kaku have brought Pluto back into public discussion. They have proposed that this icy planet might be heading toward a potential collision course with Neptune. But how can such a scenario be possible, and what would the consequences be of such a monumental event? Are we witnessing an unusual, unpredictable phenomenon, or is there something more to this impending cosmic disaster? Join us as we explore the possible outcomes of a Pluto-Neptune collision. Pluto's orbit is characterized by its distinctly elliptical shape, straying far from the nearly circular orbits of the major planets. What makes Pluto's orbit even more unusual is its tilt. Its orbit is inclined at an angle of 17 degrees to the plane of the solar system. This gives Pluto's path a far more erratic trajectory compared to the more orderly orbits of the other planets, adding complexity to its orbital dynamics. Perhaps one of the most fascinating aspects of Pluto's orbit is the way it intersects with Neptune's. For roughly 20 years during each orbit, Pluto actually travels closer to the Sun than Neptune does, defying the conventional expectation of their relative positions in the solar system. This raises the obvious question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational forces exerted by other planets. After Pluto's discovery, astronomers quickly set out to understand its strange orbital behavior. Unlike the other planets, whose orbits are relatively close to the solar plane, Pluto's orbit stands out because of its steep inclination and highly irregular shape. The puzzle deepened when it became clear that Pluto's orbit intersects Neptune's. Despite this, Pluto's orbit remains stable, demonstrating the intricate dynamics of celestial mechanics, or the so-called three-body problem in space. Understanding how three objects, like Pluto, Neptune, and the Sun, interact gravitationally is key to this scenario. It's like trying to predict where these objects will be based on where they started and how they influence one another. An additional factor at play is the VSK wobbling, a concept named after three researchers, Zell, Kai, and others, who studied how celestial bodies interact with one another's gravitational pull. This wobbling effect explains why Pluto's orbit, though seemingly chaotic, remains stable over long periods. The gravitational tugging between Pluto, Neptune, and the Sun influences Pluto's orbit, ensuring it remains relatively smooth despite its irregular shape. The VSK wobbling shows that even in the most unpredictable environments, there are underlying patterns and forces that maintain stability. This three-body problem is crucial to understanding the nature of Pluto's orbit, its relationship with Neptune, and the behavior of distant objects in our solar system. But Neptune is not the only player in this complex equation. Jupiter's massive gravity also plays a key role in stabilizing Pluto's path, while Saturn further contributes to this dynamic. These forces working together ensure that Pluto remains on a steady course for potentially millions of years, keeping it out of harm's way from Neptune's influence. Without these stabilizing forces, the solar system would be much more chaotic, with planets potentially colliding or being ejected from their orbits, triggering catastrophic consequences across the solar system. The possibility of Pluto colliding with Neptune in the future highlights the complexity of celestial mechanics and the importance of studying the stability of orbits. By understanding these intricate dynamics, we gain a better understanding of how the solar system works, the role of gravitational forces, and the behavior of distant objects. Even though Pluto's orbit may appear chaotic at first glance, it is a testament to the delicate balance of forces that keep it in place. Exploring space often leads to surprising discoveries, and Pluto's irregular orbit serves as a prime example of the mysteries of the cosmos. The concept of orbital chaos illustrates how a celestial body's orbit can be highly sensitive to its starting position. In Pluto's case, even small changes in its position or speed could drastically alter its long-term orbit. Tyson views Pluto's reclassification not as a loss, but as an essential adjustment based on our expanding knowledge of space and celestial bodies. His approach to celestial mechanics is one of constant discovery and evolution. He sees the complexities of orbits like Pluto's as indicative of how much more there is to learn about the universe. Although Tyson remains optimistic about the study of space, his views on Pluto's potential collision with Neptune suggest that there are still many unanswered questions. Will Pluto collide with Neptune, or is this merely a momentary confusion in the ever-evolving cosmic system? Only time and further research will provide the answers. For now, we are left with an even greater curiosity about how much remains unknown in our own solar system. Jupiter, the largest planet in the solar system, also exerts a significant gravitational pull, contributing to Pluto's stable orbit and preventing it from venturing too close to Neptune's domain. Saturn's gravitational influence further complicates the interactions in the outer solar system, making it likely that a devastating collision between Pluto and Neptune will not occur. While Neptune's gravitational influence plays a dominant role in stabilizing Pluto's orbit, the complex relationships between other planets, such as Jupiter and Saturn, further ensure that Pluto's path remains steady. However, research has also shown that the relationship between Pluto and Neptune is not as straightforward as a potential collision course. The gravitational resonance between the two planets, where Pluto completes 2 orbits for every 3 Neptune completes, creates a natural barrier that prevents them from colliding. This resonance, often described as a gravitational dance, ensures that Pluto and Neptune's orbits, while intersecting, never result in a collision. This mechanism is a remarkable example of how celestial bodies can maintain a harmonious relationship despite the chaotic forces at work in space. Yet, the future of this delicate balance is not guaranteed. Small shifts in the positions or velocities of these planets could disrupt this resonance and lead to unpredictable consequences. These shifts could be triggered by external forces, like the gravitational influence of an undiscovered planet or a passing star, or by internal events, such as tidal forces causing gradual changes in the orbits of these bodies. Continued study and observation of Pluto, Neptune, and the surrounding bodies in the outer solar system are essential for understanding the long-term stability of their interactions. As technology advances, scientists will be able to refine their models and gain a clearer understanding of the dynamics between these distant objects. New data may shed light on the delicate balance that keeps Pluto and Neptune from colliding, or it may uncover entirely new forces that could alter their relationship in the future. As we continue to study the dynamics of Pluto and Neptune, one key factor that has emerged is the possibility of an undiscovered object influencing their orbits. This hypothetical object, often referred to as Planet 9, is believed to exist in the far reaches of the solar system. Some scientists have speculated that its gravitational pull could alter the orbits of objects like Pluto, potentially pushing them toward new paths that might destabilize their current positions. While the existence of Planet 9 is still a subject of debate, its potential impact adds another layer of complexity to the situation. In addition to the gravitational interactions between planets, it's important to consider the broader context of how the solar system itself is evolving. The Sun, being the dominant gravitational force in the system, is gradually losing mass through the process of solar wind. As the Sun loses mass, the orbits of all the planets, including Pluto and Neptune, could slowly expand over time. This process could shift their relative positions and affect the long-term stability of their orbital resonance. Furthermore, the outer solar system is not a static place. Objects like comets and other small bodies are constantly passing through, exerting their own gravitational forces. These passing objects could occasionally disrupt the orbits of distant planets, including Pluto. Though such events would be rare and unpredictable, the combined effect of these varying forces may ensure that Pluto's orbit remains dynamic, constantly adjusting in response to the gravitational dance that occurs between the planets. In conclusion, the potential for a collision between Pluto and Neptune raises many questions about the nature of our solar system. The intricate dance of gravitational forces, the unique characteristics of each planet, and the ongoing evolution of the solar system all contribute to the complexity of this scenario. As we continue to explore and study these celestial bodies, we gain valuable insights into the workings of the universe and the delicate balance that keeps our solar system in harmony. Subscribe to our channel and thanks for watching.